Woohoo! Welcome back. Today we're going to be talking about the shortcut for multiplying two binomial expressions, which is known as FOIL or the F word. And it is an acronym for the steps, which are first, outer or outside, inner or inside, and last. Yay! So let's go ahead and talk about what's going on. So in this particular situation that I've got, the quantity x plus 2 times the quantity x plus 3, if we use the old method, this is the old, sorry, I just knocked Godzilla out of the way. I'm so sorry, Godzilla. I should be nicer to my support carnivore. Okay, so if we use the old method, you'll recall that in the previous video I said split up the first one. So I'm going to split up x times x plus 3 plus 2 times x plus 3. So this is the second polynomial, or the second binomial right there. Oop, forgot that parentheses. There we go. Or parenthesis. And so then once we do that, we use the distributive property. And we're going to go ahead and multiply like this. So then I get x times x plus x times 3 plus 2 times x plus 2 times 3. And you can keep going. In this case, we're less interested in the answer and more interested in the process. Because as you notice, we can look at this and put together a pattern. The two x's come from the two first terms. So these are first. And the 2 and the 3 are the two terms that come at the end. So we call those the last. And then we've got x times 3. Now it's the first one here and the last one here. And so people who came way before me, believe it or not, some people were born before I was. It's amazing. I know, like right around the dinosaurs. X and 3, when you multiply, we consider them the outside. So the outer or the outside. And then the 2 times x are the ones that are right in the middle there. The 2 that's there and the x right there. And that's the inner. Now, can you continue to use this method? Absolutely. This method will always work with binomials. If you multiply two binomials, you just follow this process and it's very simple. The reason that people have memorized FOIL to actually do the multiplication is that if you memorize this pattern, then your brain can start to get faster. And then you can actually do the multiplication a lot of times completely in your head. And the next question you would probably ask is, well, why do I want to bother? I could do it on the paper. Why do it in my head? My head is important. I want to save it for other things. And the answer is absolutely. Save your brain for the most important things. However, the good and the bad news is we don't just do multiplication in one direction. Eventually, we're going to go backwards. So we're going to start with this and try to figure out what the multiplication problem was. And when we get to that step, it's gonna be easier if you've been practicing starting to do this in your head. The more that your brain has been practicing with the manipulation of all these things, the quicker you'll be at recognizing the pattern going back. So that's the sole reason to do it. You don't have to, but it is something I'm going to encourage you to try at the very least. So let's look at if we're multiplying x plus 2 times the quantity x plus 3, and we're going to get x squared plus 3x plus 2x plus 6, right? That's what we got right there. And that this is FOIL. Let's talk about where they came from. Okay, I feel like I should put it right there. There we go. So we don't have to worry about the other stuff going on. So this right here is the F. That's first. The x and the x are the first ones. Then the outer is the x and the 3. This is the O. Okay. And then this right here is the I, the 2 inners. And then the last one right here is the L for last. So we do these, the first 2, then this one times this one, which are the outside ones. Then we go to the inside ones, and then we go to the last. And this follows the pattern of breaking it up into 2 pieces. So the first term goes here, here. The second term goes here, here again. So that's the other pattern you can memorize it for. So is this useful? I don't know. It's useful if it's useful. Do you like doing it in a different order? That's fine. You can do feel. In fact, back when I was young and there were dinosaurs running around, we just had barely discovered rocks at that point. So we didn't have cool acronyms. And so it turns out I learned to do feel. That was the way that I learned it. And it wasn't until I actually came to teach at City College that I learned the FOIL method and realized I do feel. Now, can you do Loif? Can you do Folly? Can you do all those others? Yes. However, I recommend that you either use FOIL or feel. So feel would be you do the inside and then the outside. I would recommend that F always comes first and L always comes last, so that in the middle, if anything's going to combine, it'll be placed in a really convenient place. They'll be close to each other. So that's why we recommend F and then either OI or IO and then L. Okay? And that is the process. So let's give it a try. And again, is it important that we actually work out the problems? Yes, that's the goal. But in this first one, we're less interested in that solution. But it would be x squared plus 5x plus 6. Okay, let's multiply using FOIL. Yay! Okay, so as usual, I'm going to write out the problem, give myself a nice big version, 2x plus 4 times the quantity, the opposite of x minus 3. And then generally when people work out FOIL, they're going to write out F, and then O, and then I, and then L. Hopefully I've given myself enough space. So what are the 2 first ones? The first ones are the 2x and the opposite of x. What's the outside? The outside are the ones, the far left and the far right. So that's going to be 2x times negative 3. I is the inner. That's going to be 4 times the opposite of x. Now you're going to notice I've just gone ahead and put pluses in between, and that's because I want to be very clear which ones are getting multiplied. So the plus is just the spacer of last resort. So I'm saying I'm going to deal with what the actual sign is later. So I'm just going to put a plus in there just to hold the space of the sign. And then for last, the 4 and the negative 3. And then I get negative 2x squared minus 6x minus 4x minus 12. And then I can combine these two. And I get the opposite of 2x squared minus 10x minus 12. Woohoo! Shall we do another one? Yes, let's do another one. Let's do a bunch of them. Okay. So, if you are watching this for my class, Catherine Saunders' class, then I'm not going to make you use FOIL. You can use FOIL in class, or you can use one of the other methods. You can use the lattice method, the chart method. You can use the method we talked about in the last video. It's completely your choice. In my experience, FOIL is the method that people can get good at and get fast at. This is the method that will help you in a few weeks when we want to start with this problem, say we start with this and have to try to get back to this one. And that's a slightly different kind of problem. But if you've been practicing with FOIL, that will give your brain the practice it needs to be able to go backwards or to continue the circle. So, okay, that's why we're going to spend so much time. Let's work on this one. Can I use FOIL? 2 terms? Yes, 2 terms. Both binomials? Awesome. You can use FOIL. So, F-O-I-L. F stands for first. So, the first one is the 3x and the x. The outside ones, I've got 3x and negative 2. Positive times the negative, that is going to give me my minus 3x times 2. So I put the sign in front. Notice I'm doing something slightly different. This is my default. I like to put the actual sign down once I have figured out the process. You could continue to write it this way. Lots of choices, really lots of choices. I should start with an equals there though. Inner, the 2 middle ones. It's a negative 3 times an x, so it's a negative 3 times x. And then the last, a negative 3 times a negative 2. Oh, we slip. Negative times a negative is a positive. So plus 3 times 2. And again, you could write it like this if you like. So I get 3x squared minus 6x minus 3x plus 6. And so combining like terms in the middle, I get 3x squared minus 9x plus 6. Woohoo! Next question. Oh my gosh, do you have to write all these steps out? No, you don't. You don't have to write FOIL out unless you know it. I'll know what you're doing. I'll recognize when you're using FOIL. It's pretty clear. Do you need to write all the steps out? No. Do you have to write any steps out? Technically, no. However, having said that, if I ask you to multiply this out on a test and all you do is give me the answer and you do not show any of your work, and if you make a mistake, I've got no way of knowing how you made that mistake or what happened. So I've got no way to help you figure out how you did it or no idea how to grade it. So it's a good idea to give at least some breadcrumbs, 1 or 2 steps, just to show the teacher what you're thinking. Otherwise, if you just give a single answer, there's really nothing to grade, no way to give you partial credit. So consider that, leave some breadcrumbs for partial credit. Other than that, hopefully you get really fast and you don't have to write anything down. That would be awesome, wouldn't it? Woohoo, yes. Okay, next up. Dum, dum, dum. Oh my goodness, what's going on with number 3? Woo, that's very stressful. What's going on? That's a good question. Chai wants to know. So what happens is sometimes your 2 binomials match. So you're squaring a binomial. Hello, Chai. My cat is behind me. She's very interested in squaring the binomial. So what do? Exactly the same thing. So that is the quantity x plus 2 squared. So this method will teach you how to square a binomial. The square, here we go, of a binomial. You can tell people you studied that and you'll sound very, very smart. I'm being like, ooh. Aren't you fancy in your college studies? You say, why, yes, I am. Okay, F-O-I-L. I'm still writing it because I'm assuming there are some folks who may not have ever seen this. So I'm just going to keep practicing it in this video. Generally speaking, unless things get really dodgy in the future, I will not write the FOIL out. I might refer to it. I might say it out loud. Sometimes I'll just multiply and assume that you know what I'm saying. Okay, first, x times x. Outer or outside. The left, far left, and the far right. X times 2. This is all pluses. Isn't that nice? Inner, 2 times x. And last, 2 times 2. And we've been using it, but we should go ahead. Let me just say out loud that I take advantage of the fact that multiplication is commutative. Commutative means that x times 2 equals 2 times x. You can change the order of multiplication, which is absolutely true for constants, like we're dealing with, and variables, like we're dealing with. Are there any maths where that doesn't happen? Well, spoiler, yes, there's some interesting times when that doesn't happen. But it's not for a long time, so you don't have to worry about it right now. But for right now, we do get this wonderful commutative property. So when I get x times 2, I write 2 times x, and then I combine like terms, and I say x squared plus 4x plus 4, and life is good. Yay! Okay. Now this one's a little bit interesting, and a lot of people look at this and they want to make it a square. A square means that you absolutely have the same thing written twice. X plus 2, x plus 2. This is not the case here. We've got x plus 3 and x minus 3. So they're not a square. This has a very awkward name. It's called the product of a sum and a difference, which sounds impossibly long until you realize it is literally a description. We are multiplying something that has a plus in it, that's the sum, and something that has a minus in it, that's the difference. So literally mathematics has names for things that are just describing what they are. So like in mathematics, this would be the long cylindrical vessel for ink instead of pen. We would just have these long names. Godzilla would be the omnivorous lizard creature that lives off the coast of Japan. So the product of a sum and a difference is what we're doing here. Let's take a look at what happens. So FOIL. First, x times x. Outer, x times negative 3. So that's going to be minus x times 3. Inner, 3 times x. And last is going to be this 3 times a negative 3. So I get x squared minus 3x, notice that commutative property again, plus 3x minus 9, and now something really cool happens. The middle terms are gone. So this is really interesting. After, and if you do like a billion of these and 11D billion of them like you'll do in the homework, blah, ha, 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 after a while you start to notice that there's a pattern. And the pattern is that when you multiply out and it's a perfect square, you end up with something that looks like this and a certain pattern. And when you multiply out the product of a sum and a difference, because one of them's a minus and one of them's a plus, the two pieces in the middle terms just disappear, and you end up with something that has no middle. So this has a double middle, right? And this has 0 middle. And so that's what we're going to do. I'm going to break the video now because we're almost at 20 minutes. So the last video will be talking about formulas. Yay! And we will talk about what happens in general when we get the square of a binomial and the product of a sum and a difference. So take the opportunity, get something to eat or drink, get a snack, take a nap, take care of that lovely brain of yours, and then come on back and we will do the last part of it. Woohoo! Yay! You're awesome. Math on.